Hi there, this is an update video of my heat exchanger based on using TO220 diodes in a series string to heat water through a heat exchanger. This is all insulated in a insulated jacket now and covered up, as you'll see in my other videos. But this is just a quick summary of some of the results I've had. Previously I'd only got results for 4 days using different diode quantities in series, and you can see I have 40 diodes. I'm getting this blue line of power, output peak power over time during the day, 39 diodes, 38 diodes and 37 diodes. And from this just 4 days of results, it looks as though 37 series diodes is giving me the greatest amount of power if we're talking about power under the curve. Now this is all down to whether it's been sunny outside, because it's been cloudy and sometimes the sun drops off. But I've increased my results now for 10 days of working, and after taking a lot of readings, this is the summary of where we've got to. I think I'll just show you this curve. These curves are from the datasheet of the solar panel, and it implies that with 1000 watts per meter squared, I might get 405 peak watts out of the panel, something like that on a good day. But as it comes down, obviously the power comes down. Now it appears that we've only been working up to maybe 130th watt peak. So we're probably only running in this area here. But I'm glad to say that the VI characteristics of the diodes, and this is a plot of current versus voltage, you can see it's running up here. We're definitely running between 25 and 35 volts over current. So we are running up and down this region here. Probably low down on radiance, so we're probably near the blue end of these graphs, but we're running up and down there. So we are running up and down the peak power point of diode dissipation. Interesting results from my wattmeter. The peak watt hours coming out so this is a watt hours measurement from a meter for each day, measured with 40 series diodes or 39 series diodes, 38 down to 37. And you'll see I started to concentrate at 37 because I'm just getting more power out of them basically. But we've got a peak power on one day of 609 watt hours from the 37. The best 38 diodes has been 560. The best 39 has been 473, and 40 diodes 388. Now obviously this is dependent on the sun. We've had some pretty overcast days and you get some pretty poor results. You can see even with 37 diodes we'll be down at 261, but generally it appears that we're getting more power out with the lower series diode combination. I probably need to go on and just take some more measurements with 36 diodes, 35 diodes, 34, and see how they match up in terms of getting peak power out of this particular solar panel. At the moment I can only make connections to between 40 and 37 diodes, and 37s are definitely best. But that's a quick summary of how I've been getting on and the characteristics of the diodes. So pretty interesting. Thanks for watching.